So before we have a look at these types of questions, okay, I just want you to think a little bit more about this. Okay, so there's the three cases that we could have. We could either have the discriminant being greater than 0, which means that we have two distinct real roots. It's equal to 0, which means we have one distinct real root, or we could say one equal root. Okay, or no, sorry, two equal roots. Okay, or we could have it being smaller than 0, in which case we've got no real roots at all. Okay, now I just want you to think, what do I mean by the word root with quadratics? Not quite, not quite. So a factor would basically be if I took something like this, okay, my factor would be x plus 2, x plus 1. So here are my factors. X plus 2 is one factor and x plus 1 is one factor. So what's my root? What's the difference between a factor and a root? It's related to factors. How would I finish this off?
X plus 2 equals 0, which means x equal -2 and x equal -1.
Good. So here, when I finish it off, when I get to this stage and I say x equals this or x equals this, these are my roots. Okay, these are my roots. Whereas when I'm at this stage, when I'm just multiplying two things like x plus something, x minus something, these are my factors. Okay, so it is important to be aware of the language, because it will crop up in questions, okay? And having a grasp of the language, having a grasp of the terminology will help you. You're like, I know what's happening here, okay? So here, when I'm looking for the roots, I'm looking for these. I'm looking for x equals this, x equals this, right? Now, what do these correspond to?
The x-intercepts?
This corresponds to the x-intercepts. So what I'm trying to say is, a root is just another way of saying x-intercept, right? It's just another way of saying x-intercepts. So think about this. If the discriminant is greater than 0, you have told me, or we've just looked at the fact, we have two distinct real roots. So what will the graph look like? Yeah, so okay, let's assume it's a positive quadratic. So would you be happy it's going to look something like this? Okay. Now obviously it could be moved slightly to the left or right or slightly up and down, but are you happy it has to intersect the x-axis twice? It's got to have two roots, okay? Because remember, roots is just another word for x-intercepts. It's got to have two of them. If it's got one distinct real root or two equal roots, what's that going to look like? What's the graph going to look like?
A line?
Well, it's got to be the same shape. It's still got to be a parabola.
Yeah, but it's like the descent is at one point.
Excellent. So I heard it from both of you. So it should just
It's good.
intercept once, right? So it's only going to come down and just touch it, okay, before going back up. It's not actually going to cut through it, right? So here is my one real root, yeah? If I've got no real roots, what's the graph going to look like? Absolutely right. So in other words, it's just going to be floating above the x-axis, yeah? Because here it doesn't intersect at all. Is that clear? So you can kind of see from the graph how many roots you need as well, okay? Good. All right, so let's have a look at these questions then. So find the values of k such that this quadratic, y equals x squared plus kx minus 3, has distinct real roots. So how many roots am I looking for? I'm looking for 2, right? Now, how am I going to go about doing this?
We're going to have if we have two distinct rules, we're going to write that equation.
Good, so I'm going to have to look at the discriminant. I'm going to have a look at the discriminant, which is, in this case, what? What's the discriminant?
B squared minus 4ac is bigger than 0.
Yeah, exactly. So I'm going to write b squared minus 4ac has got to be bigger than 0. Okay, it's got to be bigger than 0. So in this case, what's b?
K times 2 minus 2.
K squared, I think you mean. Yeah, k squared minus 4 times 12, so it's plus 12, right? Has got to be greater than 0. Okay, let's change that to a positive then. That's not quite worked out. There you go, that's better. Okay. Okay, good. So we need to think about this then. We need to think about this. This is something called a quadratic inequality. Okay? Are you all happy by what I mean by the word inequality? Yeah? It's basically just not equal. Okay? So it's not an equal, it's greater than, so therefore it's an inequality, right? Now, we have to be careful about how we solve things like this. Because what is the question that I'm asking here? This is still a quadratic, right? It's an equation with a squared in. Okay, so it's still a quadratic. I have to be careful with how I solve these. It's not quite the same as how I solve them with an equals, with an equality. How do I solve it?
It doesn't quite change it unless.
Is that your laptop?
Yeah.
Good.
It doesn't quite change it unless you're going to divide the other side over by a negative number.
Okay, so let's think about this. Let's think about this. You're right. You are right, of sorts. With a quadratic inequality, ordinarily you'd say this equals 0, stick 12 over that side, square root it, plus or minus, done, right? Here we have to be careful, because the question we're asking, this quadratic here, k squared minus 12, has got to be bigger than 0. So we're literally asking the question, where is it above the x-axis? Okay, so if I was going to plot this quadratic, k squared minus 12, okay, it's just quadratic in k, I'm basically saying, where is it above the x-axis? So first things first, I need to find the points where it goes from above to below. I need to find the roots, okay? So how am I going to find the roots of this quadratic? What do I do to find the roots of any quadratic? What do I set it equal to? I always set it equal to 0, right? I always set it equal to 0. So k squared minus 12 has got to be equal to 0 in order to find the roots. Need to find the points where it goes from above to below the axis. Need to find the crossing points. So therefore, where are the roots going to be? How am I going to solve this quadratic? Yeah, so I'm going to say k equals... Ooh, am I going to say that?
No. Negative or
Good. It's got to be plus or minus, because remember it comes from a k squared, right? So if I take the square root, I've got to also have the positive and the negative root as well. Okay. So these are my roots. Could you tidy this up using surds? Heard it? Perfect. 2 root 3. Are we happy with that? Yeah? So in other words, when I plot this, are you happy it's going to be a positive, a happy face quadratic? So if I plot this point and this point, so one of them is going to be positive 2 root 3, and the other one's going to be negative 2 root 3. Is that okay? Do you see that? So I've just found the points where it goes from above to below the axis. That's what I do when I set it equal to 0. Now I come back to this question. I come back to the question, where is it, so what values of k, is it above the x-axis? Well, can you see that all of these values over here will correspond to a positive region on the graph? Can you see that? And can you see that all of these values over here are also going to correspond to a positive region on the graph?
What do you mean a positive region?
So think about it. When I stick this value in here, for example, would you be happy that it corresponds to a positive value up here? Yeah. And if I stick this value over here, it corresponds to a positive value over here. And likewise, if I stick this value over here, it's going to correspond to a positive value over here. However, if I stick this value in, would you be happy it would correspond to a negative part of the graph? So basically what I'm saying here is that I want everything to the left of that and to the right of that. I don't want anything between negative 2 root 3 and 2 root 3. Is that clear? Okay, let me explain that again then. So are you happy that every single value over here will correspond to a positive region on that graph? Okay. Are you happy that every single value over here is going to correspond to a positive region on that graph? And are you happy because this graph is always going to be increasing in that direction, every single value on both of those sides is going to correspond to a positive region on that graph? We good with that? But are you happy that every value in here, so between negative 2 root 3 and positive 2 root 3, is going to correspond to a negative value on that graph? Because it's below the axis. It's going to be negative. So basically what I'm saying here is that the values that I want are going to be to the left of negative 2 root 3 and to the right of positive 2 root 3. I can't have anything between here and here. Is that okay? Yeah. So how am I going to write this as an inequality? I want everything to the left of negative 2 root 3.
X less than negative 2.
Yeah, it is. Just be aware that it's in k now. Okay, so it's just going to be k is less than negative 2 root 3. What if I want everything to the right?
And more than 2 square root 3. So
Absolutely. Is that clear? And that's my answer. Okay? So if I'm saying the values of k such that this has distinct real roots, what I'm literally saying here is I want this, so all the values less than negative 2 root 3 and all the values more than 2 root 3. Okay? I'm just going to combine these together with a simple word, or. Why do I have to write or, I wonder? Exactly, they can't be both. You can't have a value which is both smaller than negative 2 root 3 and bigger than 2 root 3. It doesn't make sense. Okay. Are there any questions about that? So my final answer, basically, would be this.